Hello everyone. Let us discuss about matrices and determinants. First, under that, definition of a matrix. An ordered rectangular array of elements is called a matrix. A matrix of order m by n will contain m number of rows and n number of columns. A matrix can be written as A equals to Aij of m by n, where I ranges from 1 to m and j ranges from 1 to n. Next, types of matrices. First, a row matrix. Matrix having only one row is called a row matrix. Look at an example. Matrix of order 1 by 4 in which it contains only one row. Next, column matrix. A matrix having only one column is called a column matrix. See an example. Matrix of order 4 by 1 which contains only one column. Null matrix. A matrix in which each element is equals to 0 is called a null matrix. Null matrix usually we denote with the letter O. Next, diagonal matrix. A matrix A equals to Aij of n by n is said to be a diagonal matrix if Aij equals 0 for all I not equals to j. Look at a matrix of order 3 by 3 can be written as A11, A12, A13, A21, A22, A23, A31, A32, A33, which is of order 3 by 3, in which these are said to be the diagonal elements where I value and j value is equal, and these are all the non-diagonal elements where I not equals to j. Look at an example. Non-diagonal elements are zeros. Next, scalar matrix. A matrix A equals to Aij is said to be a scalar matrix if Aij equals 0 for all I naught equals j and Aij equals to k, where for I equals to j, where k can be a scalar. See an example. These are the diagonal elements. All I equals to 3, and these are non-diagonal elements which are zeros. Next, identity matrix. A matrix A equals to Aij of n by n is said to be an identity matrix if Aij equals 0 for all I naught equals j and Aij equals to 1 for all I equals to j. Identity matrix usually we denote with the letter I. Next, upper triangular matrix. Matrix A is said to be an upper triangular matrix if Aij equals 0 for all I greater than j. So these are the elements which satisfy the condition I greater than j. Next, coming to lower triangular matrix. A matrix A equals to Aij of n by n is said to be a lower triangular matrix if A equals to lower triangular matrix. A matrix A equals to Aij of n by n is said to be a lower triangular matrix if Aij equals 0 for all I less than j. So look at an example. These are the elements which satisfy the condition I less than j. Next, important, trace of a matrix. Sum of elements, the principal diagonal of a square matrix, is called trace of a matrix. It is denoted by this notation. And mathematically, we can write trace of a matrix A as sigma I equals to 1 to n of aii. Properties of trace of a matrix. Trace of A plus B is same as trace of A plus trace of B, and trace of A minus B is same as trace of A minus trace of B. Trace of AB is same as trace of BA. Trace of KA equals to K times of trace of A, where K is any scalar. Let us see an example. Please look at the question. A1 equals to a matrix of order 1 by 1. A2 equals to a matrix of order 2 by 2. A3 equals to a matrix of order 3 by 3. So on AN, where each element AR is defined step of log R base 2, then trace of matrix A10 by 10 is equals to. The answer is 8. Let us see the working of it. First element of A10. A1 is having only one element. It is of order 1 by 1, and A2 is having 4 elements. It is of order 2 by 2. So it contains 4 elements, which is 2 square. It contains one element, which is 1 square, you can write. And A3 is of order 3 by 3, which contains 9 elements, which is 3 square. So A10 will contain 10 square number of elements, which starts with A286, and last element of A10 will be A of 1 square plus 2 square so on till 10 square, which is A385. So trace of a matrix, as we discussed earlier, is sum of the diagonal elements. So trace of A10 will be sum of the diagonal elements, which is log of 286 base 2 to log of 385 base 2, which is equals to 80. Let us see one more example. Matrix A equals to matrix of order 3 by 3, and another matrix B is of order 3 by 3. Given trace of A equals to trace of B, then what is x plus y plus z equals to? The answer is 3. Let us see how we get it. Given trace of A equals to trace of B, the condition. So trace is the sum of diagonal elements. So as we simplify this, we get x minus 1 whole square plus y minus 1 whole square plus z minus 1 whole square equals 0. And one more point here is sum of, let us see the solution of it. As per the given condition, trace of A equals to trace of B. So trace of A is x square plus y square plus z square. Trace of B is 2x plus 2y plus 2z minus 3. So on simplification, we get x minus 1 whole square plus y minus 1 whole square plus z minus 1 whole square equals 0, from which we can conclude x, y, z all equals to 1. So we get x plus y plus z is equals to 3. Next, addition of matrices. Two matrices can be added if they are of same order and the corresponding elements can be added. Properties related to addition of matrices. Matrix addition is commutative and matrix addition is associative. Zero matrix is called the additive identity. Minus A is called the additive inverse of A. And cancellation laws holds good in addition of matrices, which are A plus B equals to A plus C implies B equals to C, which is called in particular left cancellation law. And next, B plus C equals C plus A, which also can be written as B equals to C, which is called as right cancellation law. Next, few more properties. Let A and B be two matrices of same order and alpha beta be any two real numbers. Then we can write alpha into A plus B equals to alpha A plus alpha B, and alpha plus beta into A is equals to alpha A plus beta A. Alpha into beta A equals to alpha beta into A. Next, multiplication of matrices. Multiplication of matrices is possible if number of columns of the matrix A is same as number of rows of the matrix B. Next, properties of multiplication of matrices. For any three matrices ABC where multiplication is defined, AB into C equals to A into BC. So we can conclude matrix multiplication is associative. Next, distributive property. A into B plus C equals to AB plus AC, and A plus B into C equals to AC plus BC. Next, matrix multiplication is not commutative. And finally, AI equals to IA equals to A, then I is called the multiplicative identity. Thank you very much.